Let us do another numerical problem in engineering mechanics. Let me remind you, while studying engineering, you get in your semester solving numerical problems on engineering mechanics. You get about 25 minutes to solve a problem, and scientific calculator is very much allowed. So you should be familiar with scientific calculator, how to use it. It will make your calculations faster. So let us go to the problem. It is on coplanar concurrent forces, means forces lying on the same plane and passing through the same point, that is concurrent. Now look at the diagram as well as the statement here. A wire is fixed between 2 points A and D. Here is a point A, here is a point D. A wire is fixed. A wire is initially fixed like this, right? Two weights 10 kilonewton and 30 kilonewton are suspended. Suppose you suspend a weight here 10 kilonewton and a weight here 30 kilonewton. So what will happen? The string will be pulled down. So the weight that is 10 kilonewton you are suspending here will come down to the point B. The weight that is 30 kilonewton you are suspending from here will also come down. And it will take some time to stabilize, means to attain the equilibrium. After the equilibrium is reached, let this is the position. After the equilibrium is reached, let this is the position of the string. This is the orientation of the string. When equilibrium is reached, it is found that the inclination of AB, this AB part, is inclined to the vertical by 20 degree. This is given, and that of CD is 50 degree. CD is given as 50 degree to the vertical, right? Determine the tension in the segments AB, BC and CD. What is the tension in the part AB? What is the tension in the part BC? What is the tension in the part CD of the wire? And also the inclination of BC to the vertical, and BC inclination of BC to the vertical means this angle. Once this angle is known, this angle also can be found out. Okay, so let me take this angle as theta. Now look at the point. Let AB part, the tension is equal to T1. It is both way. It is actually to this side as well as to this side. And in the tension in the part BC, let it be T2, and the tension in the part CD is equal to, let it be T3, right? And you know how to resolve a vector, a force. If this is a force F, now if this is a force F, if this side represents F, this is equal to theta. So this part is your horizontal component. This part, that is same thing as this, as the vertical component. Taking cos theta from here, let this is x part, this is equal to y part. So your cos theta is equal to this x over f. So your x comes out to be f cos theta. Similarly, if you take sin theta here, your sin theta will be this perpendicular by hypotenuse. So your y becomes f sin theta. So this is how you resolve a given force into two components, one like this and one like this, perpendicular to each other, right? So now look at the point B. This point B is same thing as here. From here 10 kilonewton is hanging, so to this side is 10 kilonewton. Now this is your tension. This is your tension. I told you this is a both way force. Now this is your T1. If this is your T1, one component will be like this. If this is 20, then this will also be 20. So this T1 is same thing as this. Now, so one component is this and the other component is this of T1. Similarly, if this is your T2, this is one component of T2, this is another component of T2. Now look, this angle is given as 20. T1, if you draw a component like this and a component like this, then this angle will be equal to this angle due to alternate angle. Since this is 20, this will also be 25. So that is how I have shown here. Now, sum of the forces along x-axis is 0 because it is an equilibrium. Net force on it has to be 0, means x component will be 0 and the y components will be 0. So, if this is your T1 and this will be, that is in front of the angle, will be your T1 sin 20 and this is T2. So, this much part, this will be your T2 cos theta. So if they are only equal and opposite, if this is equal to this and they are opposite, of course they are opposite, and if they equal they will cancel, so fx will be 0. So T1, taking a scientific calculator, take the value of sin 20, put it here, T2 cos theta remains as same. So this goes to the other side, so it becomes 1 over 0.342 T2 cos theta. 1 divided by this comes out to be 2.923 T2 cos theta. I'll make it equation 1. Now once we are finished with fx, sum of the forces along x-axis, let us work out for the y-axis. Now look, this will be your T1 cos 20 and the component of T2 to this side, to this side, to this side will be T2 sin theta. T2 sin theta is downward, 10 kilonewton is downward, that is balanced by T1 cos 20. So that is balanced by T1 cos 20. So the sum of the forces along y-axis is 0 at B because it is an equilibrium. Therefore T1 cos 20 is upward, T2 sin theta is downward, 10 kilonewton is downward. So these two are the total downward, this is the total upward. So if they are equal, then the point B will be in equilibrium. Now cos 20, the value of cos 20, so let us put it, we have found out T1 is equal to 2.923 T2 cos theta. So for T1 substitute this. So for T1 substitute this. Now cos 20, you can put the value of cos 20 by using a scientific calculator, that I will do later on. T2 sin theta plus 10. Look, I am not converting kilonewton to Newton because that will be cancelled while taking a ratio. So this remains as same, T2 cos theta cos 20, this comes to this side, minus T2 sin theta is equal to 10. Make it equation 2. Now similarly look at the point C. Look at the point C. Look at the point C. Now if you look at from C, 30 kilonewton is downward. So from C, 30 kilonewton is downward. This is your T3. So this is your T3. If you draw a line like this angle is given as 50. So this will be also 50. So that is what I have shown here. Now this is your T2. So this is same thing as your T2. Now then this angle is a theta. That is I have shown here. How this is theta? If you look at the original diagram, this is parallel to this. This is the transversal. So if this angle is theta, this will be theta because they are alternate angles. So now come to, so at point C, fx is equal to sigma fx is equal to 0. The x component of T3 will be to this side, will be T3 sin 50. The x component of this will be to this side, will be T2 cos theta. Since the point C is in equilibrium, so this must be equal to this, and since they are opposite, they will cancel. So T2 cos theta is equal to T3 as sine 50. Now put the value of sine 50 using a scientific calculator. So this comes to the other side. So it becomes 1 over 0.766 T2 cos theta. So your T3 is equal to 1 over this, using a calculator, is this is T2 cos theta, make it equation 3. Now then apply the sigma Fy is equal to 0 at the point C. At the point C, 30 kilonewton is downward, and the component of T3 to this side will be equal to your T3 cos 50. So to this side, T3 cos 50 to this side is your 30 kilonewton. So and the sine component, one component like this, and T2, this also has a vertical component, that is T2 sine theta. So T3 sine 50, T2 sine theta, both are vertically upward and the 30 kilonewton is downward. So T2 sine theta plus T3 cos 50 is equal to 30. So from this, T2 sine 30 remains as same, T2, I put the value of cos 50 here, so that is equal to 30. Right. Now put T3 from 3. Now put T3 from 3 in 4. Now look T3 we just calculated as 1.305 T2 cos theta. Now put this value here in 4. So in 4, this is your 4, T2 sine theta. For T3, I write this value 1.305 T2 from here to here is your T3, that is from equation 3, and 0.642 is equal to your 30. Now so this becomes take T2 common, sine theta 1.305 into 0.642 using a scientific calculator comes out to be this, cos theta is equal to 30, right? Now from equation 2, where I had not put the value of cos 20, this was your equation 2. Put the value of cos 20. Look, put the value of cos 20 here from a scientific calculator. So this becomes 2.923 T2 cos theta remains as same. Cos 20 is equal to this minus T2 sin theta. T2 sin theta is equal to 10. Fine. 10. So this becomes T2 cos theta, this same thing as this, and this multiplied with this gives you 2.746 T2 cos theta minus T2 sin theta is equal to 10. Now from here take T2, from here take T2 common, so I am left with 2.746 cos theta minus sin theta is equal to 10, right? I'll make it equation 6. Now divide 6 by 5. So from here to here is the left side of 6, that is I have written here, divided by the left side of 5, that is from here to here, is equal to the right side of 6, that is 10, divided by the right side of 5, that is 30, that becomes 1 by 3. Now it is simple. Now T2 cancels. Now cross multiply. 3 times this, 3 times 2.746 is 8.238 cos theta minus 3 times the sin theta. This is multiplied with 1, so it becomes sin theta plus 0.8371 cos theta. Now look, take this 3 sin theta to this side, this becomes 4 sin theta. Take this part to the left hand side, So this becomes 8.238 minus, when this comes to the left side it will be subtracted, minus 0.8371, that comes out to be 7.4 cos theta is equal to 4 sin theta. Now take cos theta to this side, so sin theta over cos theta becomes tan theta. 4 comes to this side, that is 7.4 over 4, that is 1.85. So using a scientific calculator, theta is equal to tan inverse of this, that comes out to be 61.606. Once theta is found out, now you can substitute. Now look, theta is found out. Since theta is found out, put the value of theta here, use a scientific calculator. Only T2 is unknown, so T2 is found out. Now T2 is found out. Now put the value of, since T2 is found out, once theta is found out, using this scientific calculator, find out sin theta, cos theta, using this theta as the value. Then from this equation T2 is found out. Once T2 is found out, put it in equation 1, value of T2 and the value of theta using a scientific calculator, then T1 is found out. So T2 is found out, T1 is found out. Now look for T3. Now your T3 is equal to 1.305 T2 cos theta. You have just found out T2, put the value here. We have found out theta, that is equal to 61.606 degree. So put the value of theta here, use a scientific calculator. T2 is found out, put the value here, then T3 is also found out.